So let's say you're in an earthquake.
Oh no!
Now's not the time to panic, now's the time to focus. Focus, because if you're in an earthquake, you probably only have around 30 seconds to find cover before concrete starts falling on your head and just goes splat. So let's look at my room. I took a photo and I think I did pretty well in it. But let's try find the best cover right here. Under the table would be pretty good, but I think the best place would be right under my bed, right there. So now that you're safe from falling debris, let's talk about earthquakes. And if we're going to be talking about earthquakes, then we need to talk about plate boundaries. Now, as some of you may know, the crust of the earth is split into plates, and these plates have boundaries. That's what we call plate boundaries. Now, there are many different kinds of plate boundaries, from constructive to conservative to destructive plate boundaries. And one thing about earthquakes is that they're freaking powerful. A 9.0 Richter scale earthquake is equivalent to 99 million tons of TNT, or around 1.5 times more powerful than the world's largest nuclear bomb, which when blown up in London can destroy glass all the way up to the Faroe Islands, and send a shockwave around the world 3 times. Yeah, that one. Now let's talk about waves. Not those kind of waves, these kind of waves. Now these waves are produced during an earthquake. Now earthquakes come in 3 kinds of waves: P and S waves, which are the most known kinds of waves, and surface waves. Now P waves tend to be quicker and less destructive, while S waves tend to be slow and more destructive. The surface waves are what you're supposed to worry about. These waves travel on the surface and are more destructive than the other waves. Now that we have covered waves, let's talk about the countermeasures which some countries use. Now, the most known countries which use earthquake countermeasures are Taiwan and Japan. Now, first of all, let's talk about seismic sensors. Now, these are used to sense the initial waves and give warnings to people. These warnings could come in text, speakers, television broadcasts, etc. These are very effective in, protecting lives because, they're giving you like a warning kind of thing to duck and cover. Next, we have buildings. The most common form of protection for earthquakes is isolation. This isolates the foundation from the rest of the surrounding area, allowing for the waves of the earthquake not to affect the actual building. Another thing is counterweights. Counterweights will basically change the center of mass of a building, making the building stable when it's moving. Now, a famous building in Taiwan is called the Taipei 101. This building uses the counterweight system, and the counterweight system can be seen into effect when it's very windy and if there is an earthquake. Now, this ball may seem small, but it actually has 728 tons worth of steel inside, or around this many Toyotas. Well, it looks like the tremors are over. Right, if you have any rubble on top of you, you're going to have to try and push that out of the way. And the most important part after that is to predict if it's an offshore or inland earthquake. If it is an offshore one, there's going to be a tsunami, probably. And that's the most deadly part about an earthquake. For example, in Japan, there may have only been around, maybe 100 or so deaths from the 2011 earthquake, but there's been a total of 16,000 from the tsunami. Now, the highest point of elevation which I can find, and is around 20 minutes away from me, is right here, which is around 60 meters high, which is going to be plenty of amount of height. Depending where you live, and this is probably most likely in Japan, you probably have a survival kit of some sort. Now, you may want to pack that survival kit just in case if there won't be any contact for like several days or something like that. So survival kit will normally consist of a thermal blanket, canned food, bottled water, some way to light a fire, some way to say that you're here like a flare or something, a torch, maybe some tools. Now let's talk about tsunamis. Tsunamis are normally caused by earthquakes, but can be also caused by a large mass falling into water. Now tsunamis are really terrifying as well because they're so heavy. Only 1 meter cubed of this thing, and I already have 1 ton. That's around 16 people. Tsunamis have several million tons of that, travelling at 700 miles per hour offshore and around 40 to 100 on the land. It gets really scary really quickly, and buildings will be useless when trying to take cover for tsunami. But there are ways to slow down tsunamis, most obviously being a sea wall. This is just to stop the initial waves of the tsunami at that point, and then this will give enough time for citizens of wherever you're protecting to escape. Now, all of these countermeasures I mentioned before are nothing compared to the one which I'm going to mention right now, and that is good access to emergency services. Without the ease for emergency services in locations to access whatever might be badly affected, people won't get the critical attention they need, and, well, there'll be a lot more deaths. And now, this is where I'm going to end the video, and hopefully this satisfies your agenda. And be sure to like and subscribe for the video, because that will mean a lot, and I'll see you for the next video.